welcome you all for this international workshop on nanomaterials, recent trends, and some of the application of this 2D material, inorganic or nanomaterials. So we have with us conducting this workshop in a 2 days. First day today is the pre-workshop program, that is poster presentation of the participant. I think we have received huge amount of participation for this particular session. Received poster from India, Pakistan, Brazil, Mexico, China, France, and UK. So I'll just welcome all examiners. We have with us Dr. Mandar, who has completed his PhD in physics from University of Mumbai. We have with us Dr. Shanti Narayan, who has done his PhD from Central University of Bhubaneswar. We have Dr. Riddhi Kadekar, has done PhD from Mumbai University, formerly Bhabha Atomic Research Center, Mumbai. We have with us Dr. Sweta Jagtap, has done PhD in electronics from Savitribai Phule Pune University, and currently working as a faculty member in instrumentation department of the same university. She has published more than 70 research papers, also filed a patent. I heartily welcome all the examiner and hand over session to the examiner. Before I just hand over session to all examiners, I'll just introduce Dr. Arif Sheikh, who is with me. Please begin.
Hello. Hello, good evening, everyone. So, on behalf of organizing committee, our convener and myself, we all welcome you all, and we request our examiners to start evaluation, and then the participants who have who wanted to present the poster, they can be ready with their presentation. You will get a maximum of 5 minutes for the interaction. So without wasting time, I request the examiners to start the session.
Yes. Thank you, Dr. Arif. I hand over session to examiners. Dr. Mandar, Dr. Shanti Kumar, Dr. Riddhi Madam, and Dr. Sweta Jagtap. Please go ahead, and now session is with you. Thank you. Thank you for your kind help and all support. Thank you.
Thank you, sir.
Thank you, sir. Ratesh sir?
Yes, yes.
Before that, can we just give them the instructions of what is going to happen?
Okay, I think, yeah. So all participants will get maximum of 5 minutes. In 5 minutes, you show your main result discussion. So including discussion, question, answer, also you have to present 5 minutes. There is some marks result for how within 5 minutes you have to complete your present your work. And you will get marks out of 100. And we are going to announce 3 winners from faculty section as well as from the student section as well. Is this clear? And kindly mute all, request all the participants to be on mute mode. Don't switch on your microphone. Whenever you will tell, you need to switch on the microphone. That's all. Thank you.
Hello, sir. Sir, can you hear me?
Yes, yes.
Sir, we have to send the link to the 2 divisions we have made. One.
Okay, you just put a message in the chat box.
Okay.
Yes,
okay.
yes, yeah.
Okay.
Yeah, yeah.
Thank you. Thank
Dear
you.
participants, actually, there are going to be 2 different sessions going on parallelly. One is a separate session for all the PhD students, poster presentation session, and another session is for faculties and BSc MSc students. So basically, we are going to post 2 different links in the chat box, and as per your criteria, kindly join the correct link for your poster presentations. Is this clear to everyone?
Yes, sure, ma'am.
Madam, also post the same message in the chat box.
Yes, sir.
Thank you. Thank you. And you may call first participant by the time.
Yes, sir.
Austria.
सर हाँ सर वहाँ वो केवल 4 में ही चलता है, 4 में ही चलता है सर। हमारा कौन सा ग्रुप है?
Dr. Shantinaran, can you hear me?
Yes sir, yes sir.
Okay, so we are going to call first participant here, faculty here,
Yes sir,
so that
we have,
you can start the session.
yeah,
without
yeah,
wasting
yes
of-
sir. We have joined in the Google Meet that I shared, and we people have joined, students have joined, and we will start soon. Okay.
Okay, yeah, yeah. Participant kindly hold for some time. We'll be starting first presentation within a short time. Thank you. Yes, Ajila, you can ask question. If you are not, yes. Yes, Arjula, just unmute and tell me if you have any issue. If you are not able to unmute, just type your message in chat box.
Latte sir. Hello, Latte sir.
Yes, Jantinaran, yes.
Yeah, yes, sir. We are quitting from Zoom because we will start up in the Google Meet.
But PhD student will be, faculty will be continue from here, right?
No, in Zoom there will be faculty. We have we will
Okay.
conduct for MSc. No. Here it will be in Zoom. It will be PhD. But for us, the faculty and MSc, BSc, and BTech.
Okay, please give clear instruction here and start the session.
Yeah, sir. I have given.
Shanti
already.
sir, there is a small confusion. I think so. I have already shared a link for PhD students.
Okay.
Yes.
Okay.
So yes, PhD students can leave.
And join this link. Okay.
Yes.
Okay.
Yes, sir. Okay. Thank you.
Okay. Yeah.
This link is for PhD students, right?
Yes, this link is for PhD students. सर श्वेता मॅडम फोन उचलत नाही मला त्यांच्याशी कॉन्टॅक्टच करता येत नाही.
हॅलो
हा सर पण त्यांना
ऍक्च्युली रिद्धी मॅडम
एक मिनिट असं त्या बोलतायत. Yes,
आय
sir.
एम देअर
Yeah.
आय विल कॉल यू
Yeah.
Hello. 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 Can you hear me?
Yes, sir.
You're audible. Yeah.
Okay. Could you please start the session here as soon as possible? Maybe you can call first participant so that he or she will share his presentation. Okay, there is a participant, Ari Zila Nejan. He or she has raised her hand. Could you please unmute and tell what's your concern?
Sir, the first participant is Namdev Harale, sir. Is he
Okay.
present here? Namdev Harale, sir. Is he present, sir?
I guess he is not there. So maybe you can call upon next participant.
Sir, I am the next participant. I'll go ahead and share my screen.
Yes, please. Yeah. Dr. Mandar, sir. Dr. Shanti Narayan.
Good morning, good afternoon, sir. Mandar, sir, is my screen visible? Shweta, ma'am?
Yes, visible.
Okay.
Yes, Gunchita.
Yeah.
Yeah,
Okay,
you can start, Gunchita. Yeah,
all right.
I think
Thank you.
you need to slightly increase the percentage.
Yes, 1 second, sir. I'll do that. Is it visible, sir? Sir, it will be mostly visible in parts because the presentation, the
It's
poster
not
is,
visible.
is it visible?
Yeah, it's good. Okay, go ahead,
Okay,
please.
I'll start off. A very good afternoon to everyone present here. My name is Gunchita Kaur Vadva. I'm also a research scholar and a faculty at Amity University, Mumbai. And I am a research scholar under Dr. Dattatreya Latte, sir, and my co-guide is Dr. Shrikant Charade, sir. I am basically working on boron nitride. So my journey so far in my PhD has been related to working on boron nitride nanotubes, but due to unavailability of nanotubes and due to the problems which I was really overcoming related to processing them and making them or synthesizing them, I have now planned to shift my topic to boron nitride nanosheets, reinforced nanocomposites for cementitious / structural applications. So what my basic task will be is boron nitride nanotubes have proved themselves to be far more superior in terms of their properties, their characteristics than carbon nanotubes. And another additional property that was observed was the radiation shielding and absorption properties. Further, it can also be used for energy storage. So initially, when I had started off this topic, my topic was to utilize boron nitride nanotubes to make transparent composites and to replace glass structures with those composites, nanocomposites, and study if, because major radiation shielding will be from UVB, so the absorption rate, and by checking the UV spectroscopy, what exactly will be my change inside a insulated building. It can be cold, it can be hot, insulated building, and what is the radiation absorption, which is possible radiation shielding, absorption of the UVB radiation by these composites. If I'm replacing a glass basically for the exterior by this particular composite, what will be my change in the energy efficiency of that particular building. So what I was basically aiming off was to play around with two fields. I would be further, studying the percentage that needs to be added, which further I have reached to the point of adding 1 to 3%, boron nitride nanotubes or boron nitride nanosheets right now in the particular composite, so that the coagulation doesn't occur. And for my transparency, because I have to replace glass with it, a transparency of approximately 90% has to be achieved. So I had selected two polymers, basically that is polymethyl methacrylate, that is PMMA, and polystyrene. So what I'll be working on is majorly, firstly, preparing boron nitride nanosheets now from hex boron nitride via milling, ball milling process, 20 hours of milling, and further incorporating and seeing whether these boron nitride nanosheets have been achieved. Then I would be further incorporating them, playing around with the percentage as well as the thickness. So the thickness may vary from 1 to 5%. And then I'd be studying what exactly will be the effort and implications. And if firstly, characterization will only come into picture if I have to see my nanomaterial is distributed throughout. And what I'll be studying majorly will be the mechanical strength, because I'll be applying it for structural applications, UV spectroscopy, if there is any radiation shielding, if there is any radiation absorption happening. Another thing that I found out was the energy gap. So further application at the end can also be the energy absorption or storage, which can be done related to this particular idea or the nanosheet that we made. The last thing that I would want to discuss is that we've already filed a patent on this particular topic, and this patent was filed on the 2nd of March in 2021. And I would be very happy if I get a lot of feedback from the esteemed judges related to if any mistakes that I should go, and if any place that I would need any changes that need to be made. Thank you. Thank you, Soren, ma'am. Sir, ma'am.
Yeah, hello, Kunchita. Can you hear me?
Yes, sir, I can hear you.
Yes. So can you tell me why you choose this particular material, boron nitride?
Sir, I had attended a few workshops related to, so I'm basically a mechanical engineer, and I had attended a few workshops related to nanotechnology before getting myself involved into PhD in nanotechnology. This was one area of field that interested me a lot. In terms, and I've also had an additional degree in terms of sustainable development. So I wanted to relate, and I have already worked at my master's. I've done my master's from London. So what I've already done is that I've already worked on recycling of carbon fibers on a macro level. Carbon fibers, I've already worked on those. So I wanted to work on carbon nanotubes. But when I started reading about carbon nanotubes, I found another, when I went to the literature survey, I found another alternative that can be used. And the click portion for me, or the most exciting portion for me, was the utilization of boron nitride nanotubes in space suits for radiation shielding. So I came up with the idea of why not apply this radiation shielding in terms of maybe maybe aircrafts, wherein, we are actually, the outside temperature is minus 45 degrees and we are maintaining an internal temperature of 23 degrees. Why not utilize this opportunity? Why not do something? So that is how it basically started. That is how I got into this. But now
Okay.
I am stuck. I was really stuck for past 6 months because of the unavailability of boron nitride nanotubes in India. Also, the cost for 10 grams is really very, very expensive. And if you really have to make it a cost-effective product, now I'm actually started to read about boron nitride nano sheets, and making them is still much more achievable. That is, the 2D material is much more achievable. So I think what I'd be doing is much more of studying if it's already been there that the mechanical strength will increase, but I'm not really sure of what would be the implication in terms of radiation shielding.
Okay. So as compared to literature, okay, on similar things, I think you have gone through literature.
Yeah.
What novelty you could able to find in your work?
So my novelty part was basically when we're talking about the energy efficiency, everybody in terms is talking in related to increasing either the mechanical strength or increasing their, utilizing them for sensors, or to, utilize them for their basically energy gap. And, that is what people have been working upon. Nobody is actually making them utilize on a macro level, on an application based level, wherein radiation shielding can be utilized. Like, for example, if I give you an example of a country like Abu Dhabi or Dubai, wherein the outside usual temperatures is 50 degrees Celsius. And because of the aesthetic appeal, major buildings are made up of glass. So utilizing this as an exterior material for buildings and maintaining the inside temperature was the novelty part which came into picture for me. That is how I was able to file a patent. And also what I was doing was I'm decreasing the usual thickness of glass, which is approximately 12 mm, 10 mm, 8 mm, to 1, 2, and 5 mm, 1, 2.5 or 5 mm. So this is where the novelty was coming into picture, sir.
Okay, just last question. How will you
Yes, sir.
define the nanocomposites?
Yes, sir. Sorry?
Yeah, so how will you define the nanocomposite?
See, sir, composite is basically any material which is an amalgamation of two materials. So right now I'm basically working on a polymer. So this would be a polymer based composite, and adding nano material will be adding nano as a filler to my base, that is a matrix material. That is, my matrix material or the base material is polymer. So when I make and amalgamate both of them together, this becomes my nano composite, sir. As far as my understanding, sir.
Yes, so that's very good. Your presentation was good.
Thank you, sir.
Thank you. Thank you.
Thank you so much, sir.
Yeah.
Thank you.
The next speaker is of this poster presentation is Anjaniya Chesi. Anji Kundu, DVS College of Arts, Science and Shimoga. Are you there? Dr. Anjaniya, are you there? The next poster presentation from faculty category is Prerna Babaji Kane. Are you there, Prerna? Dr. Prerna? Hello, Dr. Prerna is there? Next faculty speaker is Dr. Sunil Patange. Are you there, Dr. Sunil? Dr. Sunil Patange. Dr. Subhash Pondavar. Dr. Subhash Pondavar. Dr. Ameya More.
Yes, I'm there, sir.
Are you there? Yeah, please start your presentation.
Okay. Good afternoon, everybody. How can I share? Can I share my screen?
Sir, yes, sir, you can share.
Okay. Is my screen visible, sir?
Yes, it is visible. Yes, you can
Okay.
go ahead.
Thank you very much. A very good afternoon to all of you. Topic for my presentation today is the effect of nanofillers on mechanical properties of composites. So
Sir,
basically, I'm going to.
excuse me,
Yes.
excuse me, sir.
Yes.
Just I
Yes, sir.
recommend to you to zoom it more. It is
Yeah, sure.
just zoom it.
Okay.
Yeah, this
So
is
that
good.
is-
Yes, yes. You can scroll it down. Yeah.
Yes, yes. I will scroll.
Okay, good. Thank you.
Okay, so the topic for today's presentation is effect of nanofillers on mechanical properties of composites. I'm currently working as a faculty, as a assistant professor in mechanical engineering department of Amity School of Engineering Technology, Amity University, Mumbai. And my field of interest is processing of composites and to find out the mechanical properties of the composites. So I had chosen this topic for today's presentation. What is the effect of nanofillers on the mechanical properties of composites? And especially the impact properties of the composites. Okay, so introduction is, as we all know, that composite materials are playing a very important role in composite structures, especially in the automotive, aerospace, wind turbine, and you name it, any field. Let it be sports goods or any marine application, any application. Composite materials are playing a very great role. So due to this high demand, and the main reason why they are used in this all these applications is the high specific strength to the weight ratio of these composites. So because of this, they also provide better fatigue behavior, corrosion resistance, and the resistance to thermal expansion, as well as low creep and good elevated temperatures for substituting the conventional materials. The encouraging effects of nanomaterials and reinforcing particles on the behavior of the composite materials have been studied by actually many researchers, but still, the study of composites is still a very naive field, and a lot of work has to be done more. Still more work has to be done in this area. Okay, so therefore I have chosen this area. Directly going into the nanofillers. What are the nanofillers? So nanofillers consist of nanoclay, nanoparticles, nanotubes, and nanofibers. Okay, and then coming to the methodology or the processing type, how I am going to process this. So first of all, we are going to take the nanoparticles, and nanoparticles have to be embedded into the matrix of the composite. So they have to be mixed or stirred very well. So they can be magnetically stirred, or they can also be mechanically stirred, or in some cases, ultrasonicator is also required. So that depends upon the material of the, or you can say the polymer. What is the how we can because nanoparticles are very light in weight, and also a very small size. If we directly put into the polymer, then there is a possibility of everything coming together. Okay, so and we want it to be properly dispersed throughout the matrix. So therefore, sometimes this ultrasonic plays a very important role. Now coming to the mode, how we do it at Amity. We are having a specific system called as VARTM, that is vacuum assisted resin transfer molding system. What we do basically is we have this, suppose we want to make this laminate. So what we do is we have a vacuum assisted system in which we have the plastic bagging system, and then what we do is from one end we have a vacuum pump, and from the other end we allow the resin to flow, and in between we place the fibers, whatever how many layers we want, we place them, and then with the help of the vacuum, what happens is the resin flows through those layers of the fibers, and that is how we get the composites. Now, how we are going to incorporate these nanoparticles is we are going to put the nanoparticles into the itself, and then the same mixture is going to be pulled with the help of vacuum. What I have shown over here is the difference. Okay, when we use nano rubber and nano silica, what is the difference? We can see that it is the fracture toughness has grown, or the percentage wise, it has grown 47% higher when we use nano silica. And these are the different researchers which they have done the study. The study was done on the same material. Okay, and still we see that the percentage is very different. One researcher says it is 20% increase, the other researcher says that it is 47% increase. Over here also you can see that it is 516% increase, and over here another person says that it is 250% increase. See, this difference is basically because of, I told you about the sonication. So how well our nanoparticles is mixed with the matrix material, that is very, very important. Okay, so that is how the things are currently. We can see that there is a lot of discrepancy. And over here, I just wanted to show that when, so basically these four colors consist of, this red color is the first color where there is no nanoparticle added to the composite. That is, so we can see that the strength is very less. And when we add this blue color indicates it is actually the combination of carbon nanotubes added to the matrix. And when this black color is basically when we add silica, nanosilica to our matrix. And when we add both silica as well as CNTs, then this is the strength. Okay, you can see the increase in strength. So a lot of differences. So what we are going to do over here at Amity is to prepare, the objective is to prepare the composite sheets. Basically, we are going to start with only sheet, and then we can also go for different modes, different shapes also done. Okay, so basically currently we are going for only for plain sheets. So prepare composite sheets of epoxy, woven, Kevlar, carbon, and glass fiber. Why I have chosen Kevlar? Even though Kevlar is more expensive, but I have chosen Kevlar because my aim was to go for high strength, high velocity impact resistant composites. So that is the reason why I have chosen Kevlar over here. And I'm going to mix not only CNTs, I have chosen currently written over here that I'm going to use CNTs, but in addition to that, I can also go for nano clay and silica as well. Then we are going to vary the percentage of these nanofillers, and then we are going to, as I told you that I am interested into the impact resistance, so that therefore I have chosen this mechanical test, that is drop wet test, which is going to be carried out on this composite, and then finally the mechanical and the microscopic characterization will be carried out. The methodology is very easy. Properties of nanoparticles is very important. So with the help of sonication, we are going to do that. We have a sonicator in Amity, so we are going to use that. Then after that, we are going to process the composite sheet using the VARTM technique, which is also available at Amity, Mumbai. and then we are going to go for mechanical testing, and of course the cost analysis will also be done. So with that, I am like to take the questions and conclude my presentation. Thank you very much, sir.
Yes. So Dr. Ramya More, you have presented very nicely.
Thank you very much.
So yeah, I have several questions about
Yes,
your
sir.
work. The first
Yes, sir.
thing is, which type of matrix you are using? Because what I know is there are two types of thing in the composite, that is the
Yes, sir.
dispersed phase
Yeah.
and matrix. Your
Yeah.
dispersed phase are nothing but the nanoparticles, for
Yes, sir.
which you are calling as a nanofillers.
Yes.
Right. So what type of matrix generally you use?
So basically, we go for a polymer only. That is, we use Epofine. That is epoxy only. Its number is Epofine 991, which we get from a company, a nearby company, which is called as Fine Finish. Okay, it is based in Mumbai. So we get epoxy. Its name is Epofine 991. And why we use that specific is also important, because as we all know that it is very important for us to remember that these polymers, when we add the hardener, they start the process of polymerization take place, and we have very little time, before which we have to fill that polymer to our mold. Okay, so that is the reason why I have chosen Epofine, because it doesn't require the heating for polymerization. It polymerizes at room temperature. So the only thing that we have to leave it for 24 hours, that time it polymerizes.
Yeah, that's right. The room temperature process always helps to reduce the cost of the
Yes,
processing.
yes, right.
Okay, second
Or
thing
else-
is, have you
yeah.
think about you say about this nanofillers? So have
Yes.
you tried the change in the concentration of these nanoparticles
Yes,
and
sir.
see the
Of course.
effect of it?
Yes, sir. That is a part of my study. Future study. I am going to change. I have not done it till now, but I'm going to change the combination, not only of the concentration of the nanoparticles, but also change of this reinforcing fibers. So, for example, mixing Kevlar and carbon, Kevlar carbon glass. Okay, changing the orientation from 0 to 90 or 0 60. What happens? All this. It is a big study, sir. Yeah.
Yeah. You
Yes.
can
Yes.
you
Yeah.
can do that in future.
Yes.
One more thing is there is you use some technique like
I'm sorry, sir. I'm
VAREM.
not able to hear you properly. Can you please repeat the question?
Yeah, now
Yeah.
can you hear?
Yes.
So you mentioned one technique, VARTM, right?
Yes, sir.
Vacuum assisted some
So it
processing.
is a vacuum assisted resin transfer molding technique.
Right.
I
So
can just
my
show it to
question,
you.
yeah, my question is,
Yes. Yeah.
have you seen the effect of vacuum pressure?
Yes.
So that may also, help in order to see the properties in a different way. I mean, it may change your
Yes,
orientation.
it is possible. I'll just show you. I'd like to show you
Sure.
it's not a part of poster. Okay, I have just
Yes,
I'd like to
sure.
show it to you how we do it. Okay, so you correctly said that we had to change the. You can see over here there is a pressure gauge. Can you see it, sir? Is it visible to you? I don't know.
Yes.
Yeah,
Yes, I
so there
can
is a
see.
pressure gauge. So correctly said by you that we can change the pressure, and with the help of changing pressure also we can get different properties. Probably, I don't know. See, what is the main reason why we keep this pressure gauge is, or why we use the vacuum assisted resin transfer molding is to remove the bubbles. See, we can also do this by hand layup, but when we do it with the hand layup, what happens is the air or bubbles get entrapped into our composite, and that is where our properties get deteriorated. So to remove these bubbles, there is a pressure which is specified, or we got it from the literature. So we are using that pressure, sir. But as you said, we can also try, changing the pressure.
Yeah, that's good to remove
Yes,
the
sir.
bubbles and increase the quality of your
Yes,
sample. Of
right,
course.
sir. Right.
So yes, Amaya, thank you
Yeah.
very much for your nice
Yeah.
presentation.
Thank you very much, sir, for
Thank
giving me
you.
this
Thank you.
opportunity. Thank you, sir.
I can see the hand raised by Arijela Nagendra Babu. Are you there?
Yes, sir.
Yeah, do you want to ask question or what?
Yes, sir. I have a question.
Yeah, please ask.
What are nanofillers?
Can I continue, sir?
Yeah,
Nanofillers.
sure.
So nanofillers are basically reinforcements. I hope that you understand what is reinforcement, sir. The question is coming from, I know your name, sir.
Arijela.
Yeah, Mr. Arijal.
Hello.
Voice, sir, your voice is not coming.
Oh, sorry. Can I? Am I audible right now?
Yes, sir.
So nanofillers are basically reinforcement, just like fibers which we put for a reinforcement. Okay, so these nanofillers are basically a kind of nanoparticles. In the microns or nano sizes. Okay, and why? What happens is when we put these nanofillers, say for example, carbon nanotubes or nano clay or silica of that small size of nano size, what happens is they tend to increase the strength of the material. It has been observed that it increases the strength of the material to a great extent. Say for example, if I want to give you the example of what is the weight percentage, only 0.2% of CNTs will increase the strength to, let us say, 15% or 10%. So you can understand only 0.2% weight, okay, of CNTs will increase that much, 15% increase in the strength. So that is how we do it. I hope that I answered your question.
Yes, sir. Thank you so much, sir.
Yeah, thank you.
I think if there is no more question, let us thank to Dr. Ameya More. Thank you, sir.
Thank you very much. Thank you.
So the next speaker is from faculty is Swarupa Roy, Dr. Swarupa Roy. Are you there, Dr. Swarupa Roy? Okay, let me recall if somebody has joined in between. Dr. Namdev Harare, are you there? Dr. Namdev Harare. Dr. Anjaniya Kesi. Dr. Anjaniya, are you there? Dr. Sandesh Jaybhai, are you there? Sandesh? Dr. Sunil Patange. Dr. Sunil Patange.
MSc students and BSc students, those who are presenting posters, please join another Google meeting. The link for the meeting is already shared in the chat box. For the BSc students, MSc students, separate meeting is started.
Dr. Mandar,
Sir, actually,
Can
the
you hear me?
participants which are from faculty
Mandar?
category
Yes, sir.
is already completed here.
you can continue here.
So
Okay.
you, if you like, you can continue.
No,
I
not
mean,
like.
you continue from here, sir. You can start from.
Okay,
on
because
yours.
already we were waiting there and we have conducted a few presentations. We thought why participants are not there. So that's why I joined here in Zoom, and here I can see some faculty members are also joined. And ठीक है sir, please
Sir,
you continue.
Can you join from, can you start session from here?
Yeah, Zoom. No, continue from Zoom.
Please continue from Zoom.
But we don't know which participant has already presented and how many are still to be present.
I will let you know, sir. I will let you know.
Okay, then it's fine. We can continue.
Hello, can you hear me? Hello. Okay, any participant here to present their poster? Hello. Hello. Is my voice audible?
Hello.
Yes,
Hello?
sir, you are audible.
Okay.
Uh,
Any participant here who wanted to present? Mandar sir is there?
yes, yeah, I have joined, sir. So
Okay.
I will
Please
take
say-
care of the rest.
Okay. Please take care. Yeah. Thank
Yes,
you.
sir. Yes,
Thank you.
Okay, so any BSc or MSc student who has not yet presented the poster, please.
Hello, sir.
Yes.
Myself is Puneet Kumar MS. Can I?
Yes, please. Please share your screen and please start.
Okay, sir. Thank you.
This is the common instruction for all of you. Please restrict yourself within 5 minutes only because time restriction because of the number of participants. So please restrict yourself within 5 minutes instead of going into the introductory part. Directly come to your experimental and results. Thank you.
So it is visible.
Yes. Your share screen is visible. Please, you can start.
Yeah. Good afternoon, everyone. Myself is Puneet Kumar MS, currently working under the guidance of Dr. Arvind Jadhav. I would like to present on the topic of solvent-free chemical transformation of carbon dioxide into oxygen for porous trimetallic oxide form catalyst. Nowadays, greenhouse gases and global warming is gradually increases due to burning of fossil fuels, human activities, and suddenly industrial evolution. Among the greenhouse gases, carbon dioxide is a major regulator for all environmental issues. Here we showed the graphical representation in the carbon dioxide is gradually increases. Therefore, so many researchers are trying to develop the new protocols to reduce the carbon dioxide concentration in atmosphere via carbon capture storage and carbon capture utilization technologies. Our main focus is utilization of carbon dioxide to value-added chemicals. Based on the literature survey for oxygen synthesis, here for CO2 conversion, we design the trimetallic oxide catalyst by simple and phasal synthesis methods such as solution combustion synthesis method. Here initially we consider as a copper, cobalt, nickel, nitrate precursor as the oxidants and ethylene glycol as a fuel. Blended solution stay for 10 minutes and ultrasonic for 1 hour at room temperature. The obtained homogeneous solution is dispersed on the pre-treated plate at 300 degrees by self-composition process, releases large number of gases. Finally, open the porous catalyst. That one we designed as a porous trimetallic oxide form catalyst. After synthesis of trimetallic catalyst, we perform the FSM analysis of the same catalyst. At initial 3 images are clearly showing the PTF catalyst is porous in nature. When increases the morphology of the PTF catalyst, the small pores are highly interconnected with the large pores. At the end of the image is showing the PTF catalyst observed 150 nanometer to 508 nanometer of pore diameter of the PTF catalyst. After we perform the XRD analysis of the PTF catalyst, the XRD profile is clearly showing highly crystalline nature, and this profile is clearly showing the formation of the mixed metal oxide. Okay. Mixed metal oxides such as copper oxide, cobalt oxide, nickel oxide, and less intense spinels of copper cobaltite and nickel cobaltite. From TEM analysis is clearly showing the PTF catalyst form like morphology and SID pattern of the PTF catalyst. The SKL values is clearly exactly matches with the XRD profile of the PTF catalyst. From surface technique from X-phase analysis, the PTF catalyst observed different metal states on the catalyst surface like copper, cobalt, nickel, and additionally the oxygen elements are present in the PTF catalyst. From end to absorption analysis, the PTF catalyst observed 6.50 meters per gram of surface area, and from ammonia TPD analysis, the PTF catalyst observed 0.5 millimole per gram of acidic sites, and carbon dioxide TPD analysis, the PTF catalyst observed 1.2 millimole per gram of basic sites. From H2 TPR analysis, the PTF catalyst reduced at different temperatures, like copper, cobalt, nickel, with respect to the different temperatures. After successfully catalyzation of the PDF catalyst, by using the PDF catalyst, we perform the reaction, oxidation reaction by using aniline, propane oxide, and carbon dioxide as the initial reactions. When we screen the different like monometallic oxide, trimetallic oxide, and trimetallic oxide catalyst for oxidation synthesis, we get very less yield as compared to PDF catalyst. After finalization of the PDF catalyst for oxidation synthesis, we studied the different reaction parameters such as catalyst dosage, effect of temperature, effect of pressure, and time. In catalyst dosage, at lower catalyst dosage, the product selectivity and yield is shown less. When the reaction performed at a 10 weight percent, the product is shown 96% of the desired product. When increases the catalyst dosage, the product is gradually decreases due to the formation of byproducts. In the effect of temperature, at lower temperature, product yield and selectivity shows very less due to the less energy in the reaction medium. When we perform the reaction at 120 degree, the product showed 96% selectivity and yield. When increases the temperature, the gradually product is decreases. In the effect of pressure, at a room temperature, at atmosphere pressure, the reaction is failed to achieve the desired product. When the reaction performed at 10 bar, the desired product, that means like oxygen achieved 96%. When increases the pressure up to 25 bar due to the high resolution of carbon dioxide in the reaction medium, the selectivity of the desired product is gradually decreases. In the effect of time, the catalyst showed at 12 hours reaction time at good results. Catalyst achieved 96% yield and selectivity. After form the various reaction parameters. From this study, we finalize the reaction conditions at a 10 weight percent, 120 degree reaction, 10 bar pressure, and 12 hour reaction for oxidation synthesis. Using that same reaction condition, we performed the recyclability study. The catalyst showed good recyclability studies up to 15 cycles without dropping any activity like selectivity of the desired product. After we studied the different substrate scope of the aromatic amines and epoxides, the PDF catalyst observed excellent yields in the all substrate scope. Based on the characterization and experimental results, we predict the possible reaction mechanism for oxidation synthesis. Here, initial reagents are reacted with the catalyst surface. The first intermediate of cyclic propylene carbonate is formed. After that, the propylene carbonate is reacted with aniline molecule. By elimination of the propylene glycol, the secondary intermediate of phenyl isocyanate is obtained. In the reaction mixture, again the propylene oxide is interacted with the phenyl isocyanate. Finally, by the ring closure process, the final desired product is obtained. And finally, the catalyst surface is involved in the next recycle. I am concluding my presentation. We successfully synthesized the porous trimetallic oxide catalyst by solution formation synthesis method and well characterized by various analytical and spectrochemical techniques. And additionally, we studied different optimization like various reaction parameters such as catalyst weight percent, pressure, time, temperature. Due to the presence of acidic and basic size cooperativity, the catalyst showed outstanding results. And this catalyst showed 100% conversion and 96% selectivity of the desired product, such as oxazolone under mild reaction conditions. And this catalyst is magnetically recoverable and successfully recyclable after 15 consecutive cycles. Like I sincerely acknowledge to my guide, Dr. Arvind Jadhav sir, Assistant Professor in CNMS and MT University, and my family and my friends. Thank you. Sir.
Okay, Puneet. So, can you hear me?
Hi, sir.
Yeah, so that is a nice presentation. So, can you explain the scope of your work? What is the use of this work and application of your work?
Sir, 1 second, please.
The application side of your work.
Application means whatever we have synthesized that product that is applicable like in medicinal applications and the solvents. This product act solvents, lithium and batteries, but in medicinal, pharmaceutical, agrochemicals, and they will use as intermediate substrates in other reactions.
Achha. So in the SEM image, I see there are a different size of pores,
Yes,
right?
sir. Yes,
So
sir.
how you control those things?
Control means like this pores will form in the synthesis method. Like when we obtain homogeneous solution, that metaprecursor solution, once it contact with the heat, when we at 300 degree, the formation like releases the large number of gases. that gases is the main effect in the synthesis method, like for porous nature.
Okay. And when you say it is the catalysts are magnetically recoverable,
Yes, sir.
so what do you mean by that?
Recoverable means like a normal, whatever generally we will use magnetic, right, sir? Like that time we can, after reaction, from reaction mixture, we can easily recover the catalyst, like without any making any filtration, like without any doing any workup processes. If you use as a homogeneous catalyst, we need to do so much workup procedures are there, like a separating funnel, some dense solution we have to use. Except those procedures, we can easily recover by using simple magnetic.
Okay, so you
This
mean
catalyst.
that catalysts are magnetic substances, right?
Yes, sir.
So which type of magnetism they show?
No, exactly. We didn't study, sir. Like here, we didn't study effect of like the type of magnetic properties are there. Like
Okay.
when we after performing the reaction separation process, we use a magnet, that much only, sir. Here we are not focusing any magnetic nature of this material. We are focusing for like synthesis of oxazolidine. This is our main motivations. If it is possible, we will try, sir, like in the future using this
Okay.
method.
Okay. Thank you. So
Yeah.
over to Mandar, sir.
Thank you, sir.
So Puneet can stop, right?
Yes.
Okay, so Puneet, thank you, and you can stop the presentation and listen to other participants. Okay.
Okay, sir. Thank you, sir.
Yeah, welcome.
Just let me take a name of MSc students. Any MSc students still left? Abhishek. Abhishek from Jain University is there. Rohit Nikam.
Yes, sir.
So please, can you present? Already you presented or what?
No, sir. I still didn't present.
Okay, please share your screen and
So is my screen visible?
hi, screen is visible. So please mind the time limit of 5 minutes. Okay, you can start.
Good afternoon, everyone. I'm Rohit Ramnath Nikam, working under the guidance of Dr. Arvind Yajchandra in Center for Nano and Material Sciences, Jain University, Bangalore. Topic for today's presentation, poster presentation, is tailored TBI grafted catalyst, SNT catalyst for sustainable transformation of CO2 into cyclic carbonate at atmospheric pressure. So, beginning with the introduction, the large scale of fossil fuels burning and industrialization has led to emission of different gases, basically carbon dioxide gas, which has led to various serious environmental issues like global warming, melting of ice glaciers, and deforestation has also led to the emission of excess emission of carbon dioxide. Hence, it is necessary to capture and utilize CO2 and convert it into value-added product. It is done by different industrial reactions, like it can be converted to some acids, oxazolidinones, carbonates. So our main primary focus will be on synthesis of cyclic carbonate with the help of fixation of epoxide and CO2 and convert it into cyclic carbonate in presence of TBI grafted SNT as a catalyst. So beginning with the experimental section, raw multi-walled carbon nanotubes were oxidized in presence of nitric acid at 80 degrees for 6 hours. Then the oxidized functionalized multi-walled carbon nanotubes were neutralized, centrifuged and dried and were used as template for preparation of silica nanotubes, where multi-walled carbon nanotubes were treated with CTAB, ethanol and water system and was sonicated for 6 hours. After the sonication was completed, TOS and NOS was added dropwise and was stirred, washed and dried for 24 hours, and later it was calcined at 550 degrees. It was calcined at 550 degrees to obtain pure silica nanotubes. The obtained pure silica nanotubes were further treated with a TBAI in presence of ethanol as solvent and was stirred for 1 hour, which was later dried to obtain our heterogeneous TBI grafted SNT as catalyst. The synthesized TBI grafted SNT catalyst was further characterized by different analytical techniques such as FTIR and Raman spectrum, in which the blue line showed the TBI grafted SNT catalyst, which included the alkyl groups, including alkyl groups and CN group, which shows pure SNT as well as the presence of TBI in the obtained catalyst. The Raman spectrum also showed the formation of SiO-Si bond and Bu4N, like tetrabutyl ammonium cation bond at 260 centimeter inverse and 1108 centimeter inverse. The further characterization of FSM analysis for pure FSM and TBI grafted SNT was also carried out, in which the tubular first three images shows the FSM analysis for pure SNT, which shows tubular morphology. In second three images, the grafting of TBI was seen properly. The white shiny particles on the tubular morphology was obtained due to the grafting of SNT on the grafting of TBI on pure SNT. Further, to study the characteristics of acidic sites and basic sites, TPD analysis was carried out. CO2 TPD analysis was carried out to study the basic properties of the synthesized catalyst, and ammonia TPD was carried out to study the acidic property of the synthesized catalyst. In case of CO2 TPD, the amount of acidic site was found to be 0.0191 millimole per gram. And in case of ammonia TPD, it was found to be 1.2211 millimole per gram. Similarly, the XPS analysis was studied to find the chemical bonding for pure SNT as well as TBI grafted SNT, in which for the TBI grafted SNT in Si2P, the deconvolation of Si2P showed the formation of SiEM chemical bond at 102.15 electron volt, which confirms the grafting of TBI on pure SNT. After the characterization was completed, the catalytic activity of synthesized catalyst was studied for fixation of CO2 into styrene oxide and convert it into styrene carbonate. The optimum result was obtained at 120 degrees temperature, 25 mg of grafted catalyst, 1 bar pressure, that is atmospheric pressure, and in 7 hours. The different effect of catalyst loading, base loading, time, and temperature was studied, in which in the effect of catalyst loading, 25 mg of catalyst gave best result. In case of base loading, 40 mg of base impregnation on SNT gave best results. In 7 hours gave optimum result, and 120 degree gave best reaction temperature. Herein, I would like to conclude my poster presentation. That is, we synthesized the novel robust silica-based catalyst which was incorporated with TBI, namely TBI grafted SNT catalyst, and was used for cycloaddition of CO2 into epoxide to form carbonates under ambient condition, which yielded 86% of yield for styrene carbonate in 7 hours at atmospheric pressure and 120 degree temperature under metal-free and solvent-free condition. I would like to acknowledge all the authors from Center for Nano and Material Sciences, Jain Deemed to be University, for providing the research opportunities. Thank you.
Okay, so this is a nice presentation. So you have done looks like a lot of work, and so you are doing this something related to Raman experiment. So can you explain me? Can you hear me?
Hello.
Yeah, can you hear me?
Yes, sir. Yes, sir.
Okay. So you are doing some Raman experiment. Okay. So can you briefly explain me what is Raman effect?
Sorry, sir. What is Raman
effect? Yeah. What is Raman effect?
Sir, in case of fingerprint region which cannot be detected in the FTIR region, those elements and element related things can be detected with the help of Raman shapes.
So that is fine. But my question is, what is Raman effect? Have you heard the word Raman effect?
Yes, sir. Hello.
So can you explain me what is that?
So in case of Raman effect, the Rayleigh's criteria plays a major role to determine the vibration at the particular shift.
Okay, so why you study XPS of the samples? Why you study the XPS? Yeah.
Sir, to find out the interaction between the elements in the grafted catalyst.
So what you know from the XPS study? What you find?
Sir, in case of studying mechanism, the SiN bond and SiO bond plays a major role. So we can study the Lewis basidic sites as well as the Lewis acidic sites, and to determine the kind of interaction present in the grafted catalyst and to determine the plausible reaction mechanism, it will be helpful. The interaction between those elements will be helpful to study.
Okay, so what are the different peaks in the XPS study suggest? That pink peak and blue peak. What are those things?
Sir, those peaks are obtained for particular binding energies, and it is obtained at 102.15 electron volts for SiN bond, and it suggests the kind of interaction and the between those two elements. For SiN, it's 102.15, and for SiO bond, it's like 103.6 electron volts.
Okay. Okay, so thank you. Thank you. You can now start your presentation. Okay.
Next is Pranoti Kamale. Pranoti Kamale, are you present here? From DY Patil Education Society. Pranoti. Pranoti, you have to unmute yourself.
क्वेश्चन कर फाइन व्हाट हाउ इनपुट शुड बी गिवन अभी क्या हम इतना फास्ट में कितना इनपुट क्या देंगे राइट
Shanti sir, your mic is on.
Okay. Yes. Shanti sir, Pranoti is not there. Purnendu. Purnendu. I take a name, please. Those MSc and BSc students, those who have not yet presented, please present. Purnendu. Pranoti Kamale, you are there at the meeting. Can you hear me? So I just take a name, those who are present here, please. Namashri from Jain University. Namashir from Jain University. Abhishek from Jain University. Rohit already presented. Priyal Kangane. Tejaswini Patil. DY Patil. Kolhapur. Tejaswini Patil. If present here in this meeting, please, you can present your work here in front of the committee. Pranuti Kamble, Navya Raju, Nandini Nirmal, Pratiksha Chawak, Anvesh,
अवे क्लोज पण होईना काय झाले ग हे
hello Pranuti, we can hear you, hello. Elma Dolan, Sri Charan Singh University, Yash Athreya, RV College of Engineering, Prabhakar Yadav, Mayur Khairnar, Sandeep University, Mayur Khairnar, Suraj, Sadatullah, Sumit Yadav, Purnendu, I can see you here in the meeting. Can you hear me? Supriti Mondal, Amity University, Noida, Supriti Mondal. So still those who are left to present can come forward and please present your research work.
Hello, Mandar sir.
Yes, sir.
Who is the next participant?
Already I have taken the name, sir. Purnendu is there. I can see here. Pranuti Kamble is there.
Is they facing some connectivity problem?
Maybe, shayad.
Okay.
They are not
Those who are facing some connectivity problem, they can put the message in chat box. They
Yes.
wait for still some more time.
Yes, surely.
Yes. Dr. Bharati Patil, are you presenting?
Any faculty member who is left, he has not yet presented. Any faculty member?
Yes, sir.
Yes. Saurabh Roy, are you presenting?
Yes.
Okay, okay. Yeah.
Okay, sir, please.
Can you see my screen?
Yes, sir, we can see.
Good afternoon, everyone. Am I audible?
Yes, sir. Yes, sir. Good afternoon, sir.
So my work is about the preparation of gelatin cellulose nanofiber-based functional film by incorporating mushroom-mediated sulfur nanoparticle for active packaging application. So this work is about first synthesis of sulfur nanoparticle using mushroom extract. The sulfur nanoparticle can be synthesized by many methods. In this work, we used enoki mushroom as a source for green synthesis of sulfur nanoparticle. And that one is used for the fabrication of biopolymer-based film. And as a biopolymer, we used gelatin and cellulose nanofiber binary mixture. And then different properties of the film, which is required for food packaging application, are studied. So as you can see from this schematic diagram, so this is the preparation method. Enoki mushroom extract is prepared, and then sodium thiosulfate is used as a source of sulfur, and dilute HCl is added to produce the mushroom-mediated sulfur nanoparticle. And it is characterized using various analytical technique. And from SEM, we can see the size and shape of the nanoparticle. The produced nanoparticles show good antibacterial activity, as we can see from the bacterial morphology, control, and sulfur nanoparticle treated. And it is more active toward gram-positive bacterial strain. Here, in this case, Listeria monocytogenes compared to gram-negative bacteria. So this film was used. This nanoparticle was used to fabricate the nanoparticle. This is the schematic diagram. Gelatin, cellulose nanofiber, and sulfur nanoparticles combined and produce a packaging film using solution casting method. In various film properties studied, this is the apparent appearance of the film. 3 different concentration of sulfur nanoparticles is used, 0.5, 1, and 2%. It is observed that, but by adding the sulfur nanoparticle, the color of the film become likely yellowish, as indicated from the increase in V value. And the film is compared to the neat film, gelatin, cellulose nanofiber film. The sulfur nanoparticle added films are less transparent, but it shows better UV barrier property. The tensile strength, which is important for packaging film, is improved by adding the sulfur nanoparticle. The water vapor barrier property is reduced, whereas the water contact angle is not changed. Moreover, the film showed good antibacterial activity towards the tested strain, Listeria and E. coli, and as shown in the image morphology of the bacteria, the activity is more higher in case of Listeria monocytogenes compared to E. coli. So the enoki mushroom mediated film synthesized sulfur nanoparticle can be synthesized using this simple precipitation method, and the bio-based sulfur nanoparticle can be a reinforcing material for the production of gelatin, cellulose nanofiber binary functional composite film. The tensile strength was enhanced about 25% without changing the water vapor barrier and other properties. In addition, the sulfur nanoparticle added film showed good antibacterial activity towards foodborne pathogenic bacteria, so it can be used as an active packaging material. Thank you. Any questions?
Yeah. Hi, sir. So you took out your presentation slides, right?
Yes.
Can you show?
Yes.
So how you find this mushroom extract and what is that one actually?
Mushroom extract, I used enoki mushroom and then cut in and chop in small pieces, and then boil it to make it extract, and then filtered to make the clear solution. And after that, to remove the solid particle, we use the centrifuge method. After centrifugation, the clear supernatant is used as a source of stabilizing agent for the preparation of sulfur nanoparticle.
So any mushroom or there is a specific mushroom?
Yeah, in this case we use enoki mushroom. Yes, as mentioned here, enoki mushroom. Enoki mushroom is shown here. Enoki mushroom. This is the image.
So it is available, easily available.
Actually, this work has been done in South Korea. That is easily available here. In India, I am not sure whether it is available.
Okay, so it is done in South Korea. Okay.
And yes.
Okay. So what are the size of these nanoparticles and what
The
are
size-
the shapes? I could not see it clearly.
Actually, size is roughly spherical, and shape is roughly spherical, and the size is around 20 nanometer.
Achha. So have you ever thought about making this your research into product, that is active packaging and other things? As you
Yeah,
said?
we have lab scale. We have used this kind of packaging film for.
Hello.
In lab scale, we have used this kind of packaging film to test the shelf life of different type of product like potato, then meat product we used to see the shelf life.
Yeah, so is there any possibility to transform your research to real application?
Yes, yes, it is possible. We already did in collaboration with some company in South Korea. When I was there,
Yeah.
we have collaboration with company. So we have prepared some film and lab scale, and then we produced a master batch using extrusion method. We used and then produced large scale amount of the thing, and that is used for packaging. We used meat. We prevent the greening of potatoes. So different type of application we have already used using this kind of things.
Okay, so you did the application in South Korea, but why not in India? You can start also.
Yeah, I'm planning it, sir.
Yeah.
I just joined here in Shule University this year only.
Okay.
So yeah, I'm planning this work. I have not started it.
Okay. Yeah, you can think of the real application in India also. That will
Yes,
be good.
yes.
Okay.
Yes, sure, sir. Thank you.
Okay, so yeah, nice work. Okay. Thank you.
Thank you, sir. Shall I stop sharing my screen or any question?
You can stop and sorry. You can stop and you can stay for other presentations.
Yes, sir. Okay. Thank you. Thank you.
Are any more?
Yes, so already the presentations from the faculty group started. So those faculty who have not yet presented, so just I will appeal them to present. Already some of the presentations have been conducted from the faculty category. Any student, undergraduate, postgraduate student, MSc, BSc student who is still remaining, they can present. Some of them have dropped message that they are facing connectivity issue because of the heavy rainfall. Still, we will be here for 10 to 15 minutes. So those who want to present, please come forward.
और कोई चल रहा है क्या ग्रुप में या ओनली
Each of them.
मैडम अगर बोलो
They are conducting for the PhD students.
ओह इन्हें डिफरेंट है ना
Tejaswini Patil. Now where Raju? Nandini Nirmal. Pratiksha Chawak. Ilma Dolan. Prabhakar Yadav. Mayur Khairnar. Suraj L. Namshir. Sadatullah. Sumit Yadav. Purnendu Guha. Flores. Supriti Mandal. Amar Ali. Amar Ali, I can see you here in the meeting. Amar Ali.
Hello, sir.
Yes. So you have not still presented, right?
No, I'm on the way to home. I'm not, I don't have laptop with me, so I need some time for presentation.
Okay.
Okay. Thank you, sir.
Yeah, we can wait for you for another 1 hour, Amar Ali. Yeah, okay. Those who are ready, they can present their work, please.
Actually, I don't have laptop with me now. I'm on the way to home, so I
Okay.
need some time.
Okay. No worries.
Okay, thank you, sir.
Okay, but thank you for the participating. You are participating from International Islamic University, Islamabad, from Pakistan. Nice to see that people from the border also they are participating.
Yeah, I'm from Pakistan. Yes.
It's fine that you don't have any laptop or presentation, but can you just introduce your work, whatever you are doing, or your topic of the research, or any kind of thing?
Yes, basically, just as I mentioned that I have done a research project on that title was synthesis and frequency dependent dielectric properties of manganese, cobalt, co-doped and undoped nickel oxide nanoparticles.
Yes.
So I can present my work on slides, but if it is possible, then I can speak some time without any slides, if is it possible.
So
So
you
what
are
to suggest?
so you can speak without slide also. You can go ahead.
Okay. So basically, first of all, we synthesize our desired material, which is undoped nickel oxide nanoparticles, and then we add some concentration of manganese and cobalt in undoped nickel oxide nanoparticles. So we prepared 4 samples. In first sample, we add 2% manganese and 6% cobalt in pure nickel oxide, and in second one we add 4% manganese and 4% cobalt, and at the last one we add 6% manganese and 2% cobalt. So with the different concentration of manganese and cobalt, we prepared our nanoparticles by using composite hydroxide method.
Okay.
Basically, we can use some other method like sol gel method or some hydrothermal method, but we prefer to use composite hydroxide method because it has many different advantages, such as we don't need any high temperature like in sol gel we need 800 to 1000 degrees centigrade for preparation, but in composite hydroxide method we just only need 240 degrees. So it's one of the advantages, that's why we use this method. And another advantage is that it take less time as compared to sol gel method or any other method, and also size distribution is important. We controlled the size distribution by using this. We prepared very we can say same size nanoparticles, so that's why we prefer to use this method. So after the preparation of nanoparticles, we did some characterizations, like we did XRD, then FTIR, then scanning electron microscopy, and at the last we did we measure the dielectric properties by using LCR meter. So by the help of XRD and FTIR, we basically confirmed the preparation of our nanoparticles. Basically, XRD, we know that XRD is used for the structural analysis of materials, and there are some peaks which occurred, we can say. The peaks at first at 37 degrees, next at 43 degrees, Bragg angle 43 degree, 68 degree, and 78 degrees comes in our XRD result when we draw our XRD data on with the help of origin. So we also confirmed this thing that these peaks are basically due to the presence of nickel oxide, and we also confirmed this thing from the literature. So by using this XRD, data, we also calculated the average crystalline size of our prepared nanoparticles, and then we did FTIR of these prepared samples, and we also again confirmed that our desired nanoparticles or the material was prepared, and there are some absorption band which I remember that first is at 400 to 600 per centimeter, which is due to the presence of nickel oxide, and one at I think 870s per centimeter. So by using these absorption bands, we again matches these bands from literature, and again we confirm this thing, and we can say that the result of FTIR and XRD matches. And then we did some scanning electron microscopy for the images, or we can say the SEM characterization of our prepared nanoparticles, and we saw that our prepared nanoparticles were spherical in shape and accumulated at some points, basically due to their magnetic nature. And we can also again recheck the size of nanoparticles by using this SEM. And then at the last we did the dielectric properties, basically frequency dependent dielectric properties, by using LCR meter. And we take the frequency range from 1 kilohertz to 2 megahertz, and in this frequency range we check the behavior of our prepared materials in this frequency range. So basically we check the 4 parameters. First one is the real part of dielectric constant, and second one was imaginary part of dielectric constant, which is basically we can say the energy loss, and third one is tangent loss, and at the last we check the AC conductivity. But in brief, with the addition of concentration of manganese and cobalt, we get increase in real part of dielectric constant, decrease in tangent loss, and imaginary part of dielectric constant, and again decrease in the AC conductivity of material. So by using this result, we can say that with the addition of these dopants like manganese and cobalt in the undoped nickel oxides, the dielectric properties enhance. Basically, the energy storage increase. Just as I mentioned that the real part increase, it means energy storage increase, and as the tangent loss decrease, it means the energy dissipation or energy loss decrease, which is basically our main aim in dielectrics.
Okay. So my question is, what is the effect of the percentage? Because you have used different compositions, right? So
sorry, can you repeat your question?
Yes. So what is the effect of this different composition?
Yeah, basically when we change the different concentration of these different, when we use different concentration in undoped nickel oxide nanoparticle, we change some size and atomic radii of our nanoparticles. So due to change in atomic radii or atomic size, this affects also affects the dielectric properties of nanoparticles. Basically, it enhances the dielectric properties which we get from our from the results.
Okay.
So, any other question?
No. Thank you very much for the presenting. It's a very good work you are carrying. So keep it up, and very nice to hear you.
Yeah. Sorry for not presenting my slides, because I was at university, and currently I'm to home.
Okay, that can be understood, but without having slides or any references also, you presented it nicely.
Thank you so much, sir.
So hand over to Shanti Narayan sir for the further questions.
Yeah, sure.
Which it is the microphone is off. So can you hear me, Ali?
Yes, sir, I can hear.
Yeah, so good. So can you explain me what are the imaginary and imaginary and the real part of a dielectric material signify?
Yeah, sure. Basically, the real part of dielectric constant tells the how much energy stored in the material in the when we apply the external AC field. Basically, it represents that thing, and we can calculate it by using a formula. I don't remember now, but I can. And next imaginary part basically tells how much energy loss when basically when we apply the external AC field on the material, the dipoles need to then align themselves with the external AC field. So during that flipping or alignment of that dipole, there are some energy loss which may be due to the repulsion between the dipoles. Uh, so that energy loss we consider in the imaginary part of these dielectrics.
Okay. So you in your sample that is nickel oxide, right? And you
Yeah,
put to
yeah. Basically, four samples. One is pure nickel oxide, and other threes are some with some concentration of manganese and cobalt.
okay. So do you expect some magnetic properties from those samples?
Yeah, we are basically working on some other properties. Basically, we
So
are.
you don't go for magnetic properties, right?
Yeah, we did dielectric properties, but now we are working on magnetic properties of these material also. So the magnetic properties are under work.
Okay. Okay, Ali. Okay, thank you. Thank you. And this is from my side. Good work. And try to do also your magnetic properties. Okay. And you can stay here and listen to other presentations. Okay.
Yeah, sure. I'll be here and I'll listen to everyone.
Yeah, yeah. Thank you. Thank you.
Thank you.
So anybody who left want to present, please come forward.
Shanti sir.
Yes, sir.
There are a few participants. They are joining. They are facing some problem to join. They
Okay.
will shortly join and present their work.
Okay, okay. We are here. We are here.
Yeah. So in between, if anyone is left out for presentation, they can just unmute and start their presentation.
Sir, one thing, if I reach at home before this conference end, it will be glad for me to present my work on the slides if you allow.
Yeah. You can. You first reach home, then you communicate. So we will see. Okay.
Okay. I'll expect I will be available.
Yes.
30 to 35 minutes.
Okay.
Yeah, I'll again tell you.
Okay.
Okay. Thank you.
Thank you. Welcome. We students will join, then we will start. They are joining. Google Meet.
Hello.
Yes, please. Someone is speaking.
Yeah, sir. Who is next speaker?
Sir, nobody is here. Next speaker. Maybe if someone will join, then they will start. The delegate will start. Okay. Right now there is no.
And right now Nizamuddin Ansari joined. Do you want to present, Ansari? Okay, sir.
Hello. Hello.
Hello, someone is speaking.
Hello, sir. This is-
Abhinandan Patra. Yeah.
Sir, actually, we have presented the other, that link was there for PhD students there itself. But I heard from my friends that here also my name was being called.
No. If you have presented, you are a PhD student, right?
Yes, sir.
Yeah, if you have presented, then it's okay. No need to
Okay.
present here.
Okay. Thank you.
Oh, yeah. Thank you. Hi, Nizamuddin. Are you going to present?
Hello, hello. Hello.
Hi, Nijamuddin. Are you going to present? Nijamuddin, please turn off your mic.
Okay. So I'm sharing my screen. Okay.
Purnendu?
Yes, yes.
Yeah.
Okay.
Yeah.
So are you seeing my screen?
Yes, your screen is visible.
Just a second, sir. So a warm good afternoon to everyone present here. So I'm trying to connect, but because of the heavy rain, so the internet is buffering actually.
Yes.
So sorry for being late.
It's okay. Go ahead, please.
Yes. So actually, at present, I am working at the NIBMG, or the National Institute of Biomedical Genomics. So I have, so it's not the total research oriented work. So I have just give you a brief description about the nanobiotechnology in the clinical healthcare.
Okay.
So first come to the, so what is nanoscience? So the use of the nanotechnology in healthcare is opening new frontiers across the life sciences industry. So within the ability to manipulate matters at atomic levels, nanotechnology has huge potential to revolutionize myriad aspects of medical care, including diagnostic, disease monitoring, surgical devices, regenerative medicine, and vaccine development. So first of all, a major challenge facing the healthcare industry is the human body's inability to sometimes absorb entire doses of drugs. So there is where nanotechnology comes into the picture. Nanotechnology can be used to transport the drug to specific cells in the body, which not only ensures more precise treatment, but also reduces the chances of the failure or the rejection. So first of all, here are the revolutionary and the challenging invention. So first comes at the nanomedicine. So nanomedicine applies in the nanotechnology is the healthcare application, such as treatment and diagnosis of various diseases using nanoparticle in medical devices. Now smart fields. So what is smart field actually? The term smart fields refers to the nano level electronic devices that are shaped and designed like pharmaceutical pills, but perform more advanced functions such as sensing, imaging, and drug delivery. So here here's the first invention I talked about. That is the MIT is creating the smart sensor capsule. So these smart sensor capsules actually prevent the need of the injecting drugs into the stomach. So it's delivered orally. It unfolds itself before loading itself on the organ, tracking the vital signs for the diagnosis and the monitoring treatment. And the second is the Atmogas capsule. So it is basically, it's not actually ingested, it examines the gases in the human gut to report any disorder. So its sensor actually can help the levels of the oxygen and carbon dioxide in the body as well as the presence of the any harmful substance. Any harmful substance.
Nijamuddin, hello Nijamuddin.
Now
Please switch
coming.
your yeah, go ahead.
Yes, now coming to the nanoflares. So nanoflares, it's the wonderful diagnostics method to treat the cancer. So it's designed to bind themselves to the genetic targets in cancer cells and generate light when the particular genetic target is found, thus aiding in their detection. And the most one thing, if anyone is suffering from the cancer, so we basically do the X-ray radiation therapy, but we know that the X-ray radiation therapy can damage all the other healthy tissues. So if we use the nanoparticle based X-ray therapy, so it could not damage the actually the healthy tissues, and it actually attacks on the particularly diseased tissue one. Okay, so coming to the nanobots, so first of all, the wonderful invention is the Harvard Medical School creates the origami robot. So basically the origami robot is a small capsule type, and when it enter into the body, it becomes unfolded and is severely detect the various organs activity and its molecular metabolism. And the second one is that is the University of the Toronto. It's first introduced the unfolded cubes, so which is also used for the quick biopsies of the suspected malignant masses. And now coming to the nanofibers. So in case of the nanofibers, the Institute of the Advanced Study in Science and Technology, so they has developed a pH responsive smart bandage. So pH responding smart bandage, actually in the smart bandage there is the nanoparticle bound, and in the nanoparticle bound the specific drug it's embedded, so that using that nanoparticle as a carrier, the drug it's transported to the specific target site. And using this bandage, so it can less severe first of all, and second one, it actually applies on the particular target site, so the disease curable is more enhanced. And second one is the Vexas. So it's the needle free vaccine delivery company, and is working on the commercially their nano patch vaccines. So exactly when we took the vaccines, we basically use the help of the syringe or the injection, but this patch is automatically nanoparticle based and the particular drug is attached. So the main thing is that it's essentially nanofiber patch that uses nanoparticles to deposit the vaccine directly into the immune cells present in the skin. And third one, I have told that so that is the nanoparticle mediated X-ray radiation enhancement for the cancer therapy. And now at the present time, there are so many vaccines are developing, such as Serum Institute of India also. So now the India is also focusing to develop, there is a nanoparticle based vaccine for the COVID-19. So in case we are seeing that any vaccine, if we are taking that is not effective, means after getting the vaccine, lots of cases are there, they are getting infected to the COVID-19. So it is because of there is less of the target specific. So we are taking the vaccine, but the target is not totally destroyed. But if the vaccine is made of the nanoparticles, means the nanoparticles based vaccine system, so it's totally destroy the target site and it's more effective. And some of the companies are also developing the nanoparticles based oxygen therapy also. So that's it. So it's a little introduction about the nanobiotechnology in the clinical healthcare.
What is the screen?
So that's it. So anybody has any question, so you can ask.
So can you just explain me a little bit more about the nano bandage? So
Yeah.
so the wound means it will be some external wound or
Yes, sir. It's definitely. So the main thing is that if we apply the bandage on the external wound, there is a main thing is that the particular bandage the particular bandage consisted that drug or the material. It is not totally injected or it is not totally entered into the wound. So that's why sometimes the bands is detached and the wound is taking much time to heal.
Yes.
So if we apply that is the nanoparticle based bandage, I'm telling here that the nanoparticle is actually doing as a carrier molecule here.
Okay.
So the main function of it is that to carry the drug and deliver it to the target site, so that the particular drug application can be done at the particular target site. So that's why the recovery can be more faster in this case.
Okay, so these nano bandages are available in the market or still it is
No,
under development?
Yes. So it's totally under development, and at present time at our institute, that is a nano. So that is the NIBM, or the National Institute of Biomedical Genomics. We are also planning to develop the COVID vaccine. So that is based on the nanoparticles. So it's undergone research and development totally.
Okay. Okay, Purnendu. Thank you for your presentation. Okay. So is there anyone who still left?
So sir, may I stay or leave?
Yeah, you can stay, and if there is some presentation, you can listen. Okay.
Okay.
Yeah. Other students also are also there.
Hello, Shantinarayan.
Yes,
Hello?
sir. Yes, sir.
Yes, all participants there?
I think we have completed the participants who are willing to present their PPT here.
What about the other link?
There is no more candidate coming for presentation.
What about other link by share with Riddhi Madam and Dr.
I think they are conducting.
So can they shift here?
Sir, please contact them because we don't contact, cannot contact.
Okay.
I don't know.
Yeah. I'll just talk to her. Yeah.
Yeah.
Hello. Yes, Surendra Singh. Yes.
Yeah. Can I start?
Yeah. Please, you can start. Yes.
Okay. I'll just share my screen.
Yeah, please. Shantinarayan. Hello.
Yeah. Can you see?
Yeah, we can see your presentation.
Okay. So this is regarding magnetic and dielectric. So good afternoon to all of the listeners here. The magnetic and dielectric study of nanomaterials. This is basically nanoferrites, and we have produced these nanoferrites through exploding wire technique, right? This is generally very unique. Most of the researchers, they have not tried this. What we are doing, you can see the first diagram here. We have exploded wire, copper wire inside some medium, right? Suppose here in our case it was Fe2O3, and the solution, and then the copper wire was exploded against the zinc wire. Depends on what kind of what combination of ferrite we want. So this is the second graph that we have shown is Mosbor of iron oxide Fe2O3. The first the Mosbor in the base shows the original Fe2O3. Then after this zinc copper was introduced in the material, then we can see that Mosbor has collapsed, and this all the sexlets are not appearing. They are diminishing into this. This shows that our material has reduced into non-magnetic. Right? Generally, iron oxide is magnetic, so we were getting initially all the sexlets. Now we're getting a diminished one. So this confirms that our material was synthesized, and this is zinc copper ferrite, right? It was doped with zinc and copper. Especially now, we wanted one magnetic and one non-magnetic material to be doped in the ferrite. So that's why we have taken copper and zinc. Zinc is non-magnetic and copper is magnetic in nature. So then we did impedance spectroscopy analysis, and here we could see there was a decrease in real part of the impedance, which decreases with the frequency at all temperatures that we have studied. Insignificant, and this is because of insufficient time for the space polarization to relax at the higher frequencies. There is mismatch between the frequency of the supplied AC energy and the oscillation of the this charge carriers within the material. And a recombination takes place at a higher, at faster rate, leading to reduction in the space charge polarization. And maximum, we can see the maximum of this M, the electrical modulus at all specified temperatures are obtained at higher temperatures. The combination of electrode polarization in electrical conduction is ruled out. Then we have this. We have taken one temperature particularly to so that modulus intercept actually gives grain boundary capacitance, and with the help of that, that peak of that, we could find the frequency and the relaxation time, and the radiations of the grain boundary was calculated to be 0.03 kilo ohms, and the capacitance of the grain boundary it was found to be 8.2 nanofarad, and relaxation time was calculated to be 1.9 microsecond. And the dielectric plot, like dielectric constant versus frequency, we could see that we have taken 4 temperatures here. It was found that at all temperatures, the dielectric constant is higher at lower frequency and rapidly attenuates with the frequency. The effect of a space charge is responsible for this that we have already discussed, because at higher frequency they cannot. This charge carriers cannot match the applied frequency. The polarization is minimum at the higher frequency, and dielectric dispersion mainly is governed by intrinsic mechanism of polarization at higher frequencies. The next graph, we have a modulus graph of the electrical modulus at 5 different temperatures, and we could see the peak of these graphs shifts to the higher frequency. And this shows that relaxation process is also activated at temperature, and also it shows that our conduction in the material is motivated by this hooping of the charge carriers. And then we have AC conductivity study versus frequency. Here we could see and this was this is governed by the relation of AC conductivity, that is Joshner. We'll study this later with the Joshner plot also. And this conductivity of AC is of the nano is increasing with frequency. Therefore, hooping charges is caused by this is confirmed that hooping charges actually causing the conductivity of the material. Then we took the log plot of at 2 temperatures of this AC conductivity versus log of the frequency. Then we got a linear graph, and from here, the value of n, the power of n from the Joshner empirical formula relation, And here it is through the literature we have got a strong evidence that if the value of n happens to be lesser than 1, then the hopping conduction is confirmed. But in both the cases, the value of n are found to be 0.39, and it was okay. And in the other one, it is 0.81 at room temperature. At both temperatures, it was less, and so hopping conduction is confirmed. Then we studied magnetic study, and here in case of magnetic, we can see that this at lower temperature magnetization has improved, and it is following the hysteresis loop also. Then and the second one here with after doping. It is found that magnetic nature in one cases magnetic hysteresis loop is more dominant, and all these properties of our material encourages us to for application of ferrite bead. Ferrite bead actually, like this material can cancel the noise, and this can be used in cables that we have shown in the diagram. And this noise cancellation is actually based by through this. We are assuming that material is having the property of inductance, and obviously it will have some resistance, and those two resistances of when the inductor is shown by this relation. That is, the inductance is contributed by the resistive nature of the material and inductive resistance of the material. So these two this type of resistances actually nullify the noise, that frequency, noise cancellation of frequency. And to summarize, we have I can summarize with this that the current produces magnetic flux in the circumferential direction, and the magnetic flux passing through the bead material produces internal inductance. And the nanoferrite produce selective attenuation to high frequency signal and do not affect the more important or the required or essential frequencies of the component. And these are the three conclusions that have. There is no contribution of electrode polarization in the electrical conduction process of zinc copper nanoferrite prepared by exploding wire technique method. And since the plot of M double dash, the imaginary part of electrical modulus versus the real part of electrical modulus has only one grain boundary, plays a vital role in the electrical behavior of the prepared sample. The value of grain boundary resistance, grain boundary capacitance, and the relaxation time are calculated by 0.3 kilo ohm, 8.2 nanoferrite, 1.9 microsecond respectively, which are excellent agreement with the literature reports. The strong magnetization at low temperature, that is that is what the graph shows, and this what you call blocking temperature was found to be 85. Yeah.
Your magnetism data is not visible on the screen, so can you down the PPT?
Can you see now?
Okay, yeah.
And the strong magnetization at low temperature can be seen. And blocking temperature was 85 Kelvin at for the zinc grease ferrite, and one point it was 103 Kelvin at copper grease ferrite. So these are the three papers that we have published on this dielectric and magnetism. Thank you so much. Thank you, sir.
Yeah. So this is a nice presentation. So when you say nanoferrite, what do you mean by that? Nanoferrite.
Nanoferrite, the size of the particle that we got was in the range of it was 3 to 15 within 15 nanometer size.
How much? Maximum size and minimum size, is there anything?
It was okay, 5 to 15. It was in the range of 5 to 15. The same graph. I have not shown the same here. Like here we have.
Okay.
Yes.
So you also said something like copper is a magnetic, right? So can
Copper
you-
is okay. Yeah. Copper is like because of its it is because of unpaired d orbitals, electrons in d orbital, and zinc has I think 30 and copper has 29. So because of that, they're very close to each other, but the copper shows slightly towards magnetic, whereas zinc is non-magnetic. They completely paired d orbitals, and they can nullify each other, so we get non-magnetic. So non-magnetic zinc.
Yeah.
Copper shows it's at nanoscale level. Copper is showing magnetic behavior. We have one of the study we did copper oxide. There we got magnetic properties, very nice magnetic properties of copper oxide.
So that magnetism means which type of magnetism?
It is
related to
no, it's
ferro or
it's para. It's para.
paramagnetism?
Yeah, and it depends on the yeah. That's why this magnetic property can be scaled. Like tailored. At some range of nanoparticles, it is ferro also, and at temperature also. So that's why like there are many aspects which can be magnetic property can be controlled in nanoscale, right? We cannot define a material to be completely magnetic, but different size and different temperature they are behaving completely differently.
Yes. So what are the possible applications of these nanoferrites?
Here, like here we have application is this is localized. Now there is one very important application that we have looking forward for application also, that is microwave and electromagnetic as an electromagnetic material, right? There are certain this frequency range of microwave which can be easily absorbed by this material. So we are looking forward for the application of that. Like there was certain window of the microwave frequency which is very compatible with this material. So either it can be used for even cancer detection, cancer therapy, like thermal therapy, where like these nanoparticles can be taken as a drug, and it can be transported to the location of this tumor cells, and and then if you apply external microwave field, then the vibration of that can lead to heat generation, and that can kill the cancer cells. So this is another possibility, and then we are looking forward to collaborate with some biomedicine.
Nanomedicine, application of nanomedicine.
Yeah, so there we can collaborate with them, and we can take this material for further study. We're looking forward to it.
Yes.
Like AIMS in Delhi, like we have trying to reach AIMS Delhi for that.
So that is really exciting application of nano medicines.
Yeah.
Okay, so thank you for a nice.
Thank you so much. Yeah, like I think what's your good name, sir? Like
my name is Dr. Santinarana Raut.
yeah, okay. I'm supposed to talk to you after. Okay. Yeah, you remember, right? Okay. So so I will be joining tomorrow also, like listening all people.
Yes.
That will help us in our research.
Yes. All please join.
Okay, thanks.
Those who are here in the group.
Okay, I will ask them to join. Okay. Thank you so much, sir.
So so I hope there is no presentation left, and we will be closing soon. So I thank all the delegates who are here and presented their work. So thanks again. Okay.
Thanks.
See you tomorrow. Thank you.
Thank you.